So in this video, we are going to receive data from Iridium satellite, and we are going to use the tool known as GR-Iridium. So this is a tool to receive data from Iridium satellites. And first of all, we have to connect our L-band antenna with our RTL SDR dongle, or if we are using HEC-RF1, we can connect our L-band antenna to HEC-RF1 as well. And then we have to compile this tool, right? So the compilation process is written over here, but since we are using Dragon OS, this tool is already compiled and installed in this OS, so we don't have to compile it again. We just have to use this tool. So if we were using Ubuntu or Kali Linux, then we have to follow the compilation process as well. So that's why we are using Dragon OS, and it contains all the SDR tools, almost all the SDR tools, which are very known tools. So yeah, so let's just open our terminal and let's just go into this tool directory. So we have to do cd user src gr-iridium, and let's just do ls. So this is a tool, and we just have to use this tool. This tool is already compiled and installed in this OS, as I told you before. So let me go into examples directory and let's just do ls. So over here you are seeing all the files related to the SDR device which you want to use. Basically there is airspy.config file, hackrf.config file, rtl-sdr.config file, and there is also lime SDR and blade RF as well. So depending on what device you are using, you have to use this file in the command, which I'm going to show you in a moment. So these are all the configuration files according to your device. Since we are using RTL SDR, let me do sudo nano rtl sdr.config, and we have to type the password. So this is the file. So you have to uncomment out this line over here. You can see device arguments, and you have to make sure this line is uncomment because there is a bias 1, so the antenna can use bias power. So that's why we are uncommenting out this line. So depending on what device you are using, you have to use that file and uncomment out this line basically. So let me save this file. So it's not saved. Let me save this file. So it's saved now. Let me show you HEC-RF1 file as well. So if you are using HEC-RF1, you have to edit HEC-RF1 file, and you have to uncomment out this bias power in HEC-RF1 as well if you are using HEC-RF1. So let me do it that as well. So yeah, so this is how you edit files. Since we are using RTL SDR dongle, we are just focusing on RTL SDR.config file, and make sure before running any command your RTL SDR dongle is also connected with your operating system. So let me connect my RTL SDR dongle. So the device is connected and it's showing me the option to connect it with the host or with the virtual machine. Since we are interested in virtual machine, I'll just select the virtual machine and click on OK. So the device is connected. Now let's just run the command. So the command is iridium extractor hyphen capital D with 4 space 4 and then the device name or the device config file. Since we are in example folder, we just have to use RTL SDR config file over here, right? So we are if you are using hackrf1 device, make sure you are using the hackrf1.config file, right? So this is the hackrf1.config file, but we are using RTL SDR. So let me use the RTL SDR.config file, and then we will pipe this command with grep. So grep will only capture the packets which are okay and which contain some data, right? So we have to type a colon okay and close the quotation. So grep will only get those packets which contain some data and their average is okay, right? So you will get this command in a moment. Let me complete the command first. Then you have to save this data into some file. So we are going to save this file on our desktop. So let me go on my desktop and let's just name this file as output.bits. So the extension is bits, right? So let's just go this command one more time. So iridium extractor hyphen capital D 4 and then the file or the device which you are using, the config file of the device which you are using. Then we will grep this command with a colon OK. So we will just get the packets which has the good average, and then we will save those packets into our output.bits file. So let's just run this command. So our device is started and we have started receiving the packets. Over here you can see. Let it run for some time, maybe 1 or 2 hours, so that you can get some good amount of data and then we can extract that data and decode that data. So let me run it for a while, and in the next video we will see what data we have got and we will see how to decode that data.